Welcome all to our latest rendition of Webinar Wednesdays. My name is David Phelan from Belfast Met College. I work for the Centre for Economic Development and Social Inclusion team, which I know is a bit of a mouthful, but we call ourselves CEDSI for short. And essentially we help through a range of programs, companies upskill, train, innovate, and look at development of new products, processes, and services. Webinar Wednesdays has been developed under the Connected program, which is funded by Department for the Economy, and essentially the crux of the program is to help the likes of ourselves as a college, the whole college network, and universities in Northern Ireland engage with private sector business and share our knowledge in a range of different areas. One of the areas that Belfast Met looks at as a college is technologies and emerging technologies, such as blockchain, machine learning, data analytics, through to some of the more emerging software development techniques. And thankfully today we have one of our technical leads when it comes to blockchain, Martin Naughton, who's going to lead us through looking at, I suppose, what really is blockchain, but also how it can be applied to supply chain management. So without further ado, I'll let Martin kick off our session.
Cool. Thanks, David, for that. Yeah, Webinars Wednesdays, nice ring to it there. So my name is Martin Naughton, and I'm a part-time lecturer in the Belfast Met. So I kind of handle the areas around blockchain, AI, machine learning, IoT as a part-time basis, and I run a software development company in Belfast the other part of the time. So through this presentation, I just want to show you the basics of it. So you'll have an understanding, a good foundation, and then all the other concepts really kind of align with it then when you kind of research it yourself. So about 25 minutes, we'll kind of go through this, and I'll give you a good few examples as well. And I've done a few through the Belfast Met, and I'm doing it through a few proof of concept ideas for companies around Belfast, just kind of show how it can be applied to their kind of their company and stuff. So I do a bit of research and development through the Belfast Met on that. So I'll just get started then on that. So I just want to show you a quick example of a supply chain, especially in this whole COVID-19 issue we have at the moment. And I don't know if everybody saw down the Boucher Road in Belfast there about a week ago when KFC drive-thru opened up, there was a queue down the Boucher Road, people waiting to get into the drive-thru. So people love KFC. So this kind of, so they don't have a supply chain issue at the moment, but KFC did have one back in 2018, when around 680 outlets around the whole UK didn't have any chicken. So KFC's number one selling thing is chicken. So, and they have about 900 stores. So about 2/3 of their stores didn't have chicken. Now this came down to a problem of they changed their contract, their delivery, the person who delivered those chickens from one company to DHL. Now they had a big problem where they never thought about how much chicken was really going to come into one depot. So to save on cost, DHL was like, yeah, we're going to put them into a place called Ruby Warehouse near Birmingham. And that's when the problem started to happen. There was too much coming into the one warehouse, and it wasn't really well thought about there. So if you can see here, then this is the kind of a picture again from the BBC, just the kind of queue trying to get into this warehouse. Like they have all the chicken, it just can't get into one place. Now, it's not that blockchain will solve this issue for them like completely. It's just showing you how critical the supply chain is. Now, you know, they lost around 2 million or 3 million pounds because of this. You know, they couldn't open their stores, some stores couldn't open. So again, it's showing how supply chain is so critical. And you know, like they had software problems with their trucks as well, so they're waiting hours to load. And again, what happened with that chicken after a while, it was supposed to go from one place to the warehouse, and it got spoiled then waiting around. So they had to, took a few days as well to put in a fix. So it wasn't as soon as they found the problem. So again, supply chain is really, really important at the moment for everyone. But again, it's important now with the COVID-19 kind of stuff. So again, just showing you how the supply chain is quite important. So just to kind of get some basics in there, this is just a picture of a ledger. And really like what a ledger is, and it applies to blockchain because it's all about ledger, is it's a series of transactions. So maybe 50 years ago, we would have used ledgers to kind of handle our transactions between businesses, who owed us money and who didn't owe us, or who owed us money and who we owed money to. So we would look at these transactions. So we maybe keep them in a booklet, and that's how we look after our transactions. So that's really what the basics of it is. Blockchain is, it's a series of transactions. You're just keeping a history, because a ledger is a history of transactions. So if we ever wanted to go back, if we had a physical ledger and see how the transaction worked, we'd open it up and we would go through, we'd find the different transactions that happened in it. So again, that's a ledger, and that's what kind of the basics of blockchain. I'll keep coming back to the whole ledger concept as well, and it helps explain blockchain a bit better. So then just kind of like, what is blockchain as a whole? A ledger is just one part of it there. So again, I found this nice picture on the internet. There is a blockchain is a database, but a database is not a blockchain. So if you think about it in databases today, you know, we might have our Sage accounts. They're all like backed up by databases. That's how we get our information. They show us in a user interface then. So that's a database of that we keep there. So it could be a series of database of transactions or asset tracking we're doing. It could be anything, a database. It can track anything there. So again, blockchain is a database. It's keeping information of transactions in a database. But the difference is it's keeping a history of those transactions. In a normal database, you do not have history of transactions. Now you can create other tables to make to look after those histories of transactions, but the only thing is they're not very secure. So again, I was just thinking there yesterday, just to show you the difference, just on a very basic scale on security, is you can change anything in a database, a normal database today, and nobody knows any different. Within a blockchain, you have a history of those kind of transactions. So again, just give you an example, just my cousin, I was talking to him last year, and his daughter is very good at computers, she's about 14 now. She was able to hack into the school grading system. She got through to the database, she was able to change her grades, and she was able to save them. There was no history that she'd ever done that, but she got into the database. The database is not, so you might say, oh, there was a history of her grades. There must have been. She can go in and change those. They're just tables. There's no security as a basic concept. The database, there's no security there. You have to put security around it. But if you get to the database, you can change it. So the only way they found out that she changed her grades was the teachers kind of saw the grades when they were handed out. They didn't relate to the grades she had. And then they had to, they found out she'd done it like so. Again, it's just showing how mutable or changeable the database is on a level. And we have no history about it because it's not built for that. So again, we'll just explain through like whole blockchain how the it's security by design. Like it is supposed to have a series of transactions and a history of that. So I'll explain that later on and think. So again, be thinking about that, how databases are kind of nearly not a security concern. You have to put it around it. Where blockchain, it's built into the whole thing. So yeah, supply chain process. I just want to bring you through that with it a bit. So supply chain is a series of transactions. Again, like a ledger, we have a series of transactions, but on a large scale, supply chain is coming from a supplier to a customer. So if you think about it, the red arrows there means information is going back and forth between the different stages of supply chain, and goods go to the right direction, goes from the supplier to the customer, and then money goes from the customer back to the supplier. So it goes through that that whole distribution process then. So multiple manufacturers can be involved as well when you're procuring at the start, say suppliers, and you can have, and it can be quite large, you know, if anything fails within this supply chain, then the whole rest of the leading bit of the supply chain is affected as well. So yeah, so that's what we kind of even see today in COVID-19. The whole supply chain is kind of affected. Even I was watching something there on BBC on the weekend, and they said as well, the price in Holland, the price of fish has kind of collapsed, nearly halved. So the fishermen are not going out fishing anymore because it's not worth their while. Again, if we come back from this COVID-19 in a few weeks or something, it's going to take that supply chain again to kind of take a while to start up again. So we have to be mindful of that. Like. So again, we're just thinking about supply chain process. That's what it is, and how. Then I just want to explain how blockchain works, and then we'll think about how we can apply it to that whole supply chain process. Just to give you a really basic understanding of the information and a bit about the blockchain here and how we keep the information and how it's encrypted as well, or hashed, is hash information. So hashing really is, it's like a fingerprint of data. So if I put my name, Martin Naughton, into a text file and I hash that information, it will come out with the same hashed text, if you see on the right hand side here, every time. It's like a fingerprint of that information of those letters, how they're organized and the spaces between them. That's it. So that's what we do with the blockchain, is when we save stuff onto the blockchain, we get a hash of that information. So it puts through a hash algorithm and we store it onto the blockchain. So that's how we know. That's how it's encrypted and or hashed, and that's how we store it. So if you can see from the left-hand side to the right-hand side, we can only go one way. You cannot unhash this information and get the plain text back. So it's a one-way hash. So again, what we really want to be doing is putting information on the blockchain that is hashed as well. So then we can say that's the history of it. We don't want to be putting any plain data on it as well. So we want to, that's how we kind of, through transparency as well and through security. So again, that's a really basic one. Again, think of it as a fingerprint of data. Every piece of data has a fingerprint, and it's always going to be the same fingerprint running through the same hashing algorithm as well. So again, this how this applies to other parts of the security on blockchain is, again, think of blockchain as a chain of blocks, really, and every block is a transaction that happens and it's saved onto the blockchain. So that's on its simplest there. And then you're kind of probably wondering like, oh, how does it know? How does it keep security? How does the chain keep security? Like if the chain is broken, that's when you have an invalid blockchain there, and that's how you know someone's hacked into it. So again, in a database, like we talked about earlier there, I can go into a database, customer database, I can change some information in there. Again, nobody has any knowledge that I've maybe changed it unless they have some security around it. Again, that's them putting it there themselves. Within blockchain, it's built in. So if you can see here, maybe on block 4, the chain is based on the information in the block. So remember, I was talking about previous there, I hash the information and then I put it on the blockchain. So I put it in the block here. I store it on the block, but also the block wants to know about the previous block hash information. So that's how you connect the blocks together. So say I come in and I want to hack the blockchain. Now this is a very simple blockchain. There's only 6 blocks there, but on normal blockchains there's thousands and thousands of hundreds of millions and stuff on it. If I want to hack a blockchain and change the information in block 4, because again, this is a series of transactions, which is a series of histories, yeah, just like in our ledger. Now I want to maybe change that in the blockchain that I owe someone or I owe a customer money, or in the supply chain, say. If I want, and the information is in block 5, and I go, I'm going to change that information, I'm going to bring it down from £100 to £10. Once I change that, the hash of the information changes. Again, remember, it's a fingerprint of the data. So that hash changes in the blockchain. So blockchain 6 is only linked to blockchain 5 when it has the hash number. But if I've changed the hash number here, this hash number does not relate to this blockchain 5 anymore. So that's how the chain is broken, because I've changed the information here. There's no connection between them again. Now, what I can do as a hacker, I can go to block 6 and I can change that information so it points back to block 5 completely. So then I solve that problem. But if I have block 7, I have block 8, I have to now go through the whole blockchain to change that information to make sure it's a valid blockchain. So again, if we have hundreds of thousands of blocks on the chain, I have to go through them in series and completely change them. And again, if I don't, then this chain is broken. Then you can be, then you know it's hacked. Somebody's hacked it because the chain is broken. Like, so again, be thinking about that. That's how the actual chain bit works. It's checking the previous the current blockchain is making sure I have this exact hash function that relates to the previous one. And if I do, then I have a valid chain. If that information in that block changes, then I have an invalid hash, means I'm broken. So that's when they call it the blockchain. It's just a series of, it's a chain of blocks. So again, it's a series of transactions. Again, that's what we store in the chain then. So just to kind of how blockchain works and, you know, like on a general scale, okay, we got the basics. We know that information has to be hashed and stored on the blockchain. We know a block has to know about its previous block to be valid and that there's security there. We know if I change one, I have to change multiple ones then. So that's good. And we know it's a database, so it can keep information on it as well. You know, like transaction information, you know, if I bought something, if I transacted with another customer, that transaction then can be put on the blockchain and saved there, and there's history of it. And it can't be changed unless I change all the blocks on the chain. So, okay, so we got those kind of concepts, very basic concepts. Again, if you think how blockchain works here, on a simple one, A wants to send money to B. The transaction is represented online as a block, just like I said. The block is broadcasted to every party. I haven't talked about that yet. I'll talk about it in a minute. That's the power of the network. With blockchain, everybody on the network of blockchain has a copy of that database, that history of that database. Everybody has a copy of those chains. So if any of those change, or say new block added, everybody gets a copy. So everybody is up to date on the network. So I'll explain a bit more later. The network approves the transactions. Again, you're getting everybody to approve it. Again, in a centralized way, which I'll explain in a minute. If I change it, like again, changing the grades in school, it's a centralized one database. If I change it there, nobody knows. But on number 4, then the network approves the transaction. Everybody knows about it, and everybody gets their copy adds to the block or adds it to the chain. And number 5, yeah, the block is added to the existing chain in a transparent and alterable way. Then again, we're saying like we have the hash, there's a link, you know, that kind of way. And then the transaction is completed. And again, that's on a very basic scale how blockchain kind of works. We do a transaction, a block goes on the network, everybody, and it's broadcast to the whole network there, and then everybody approves it, and then the block is added to the chain. Only when the block is added to the chain, then it's an approved transaction. So I'll just kind of go through the network there on and what I was just talking about there, the whole blockchain network. So I just think, and I mentioned briefly there on the traditional versus blockchain. Traditionally now, we really have centralized systems. So centralized as in like, we might have a business, our database is on premise, that's maybe where everything goes, you know, all our transaction information and how we run our business. Now, anybody can hack into that kind of, if they get into the server, they can change information in the database there. And nobody be none the wiser then, because there's no history of it as well, as security is not security is not a layer within the database application. So again, in a centralized way, like, you know, it's a real security problem in a centralized way. Like, you know, if I only, as a hacker, I only have to get into one place. Once I change it there, it's done, like, you know. In a blockchain kind of system, everybody has a copy of that. Who's on the network has a copy of that database then. So again, I have to, if I'm a hacker, I have to now hack into, in this one, 4 databases, then change the information. But I also have to change all the blocks in those databases. Again, I've got 2 layers of security there. So again, on some normal blockchains as well, there's maybe, you know, Bitcoin there, everybody has the Bitcoin ledger, a copy of the Bitcoin ledger. So there's, you know, I don't know how many copies there are on the internet there of it at the moment. But again, somebody, if they wanted to change it, would have to hack into all those nodes. There's probably maybe 100,000, just going to give a guess at the moment. So again, that's just another layer of security. It's distributed. So again, you're making it harder for hackers and to break into all the systems as well. So again, strengths in numbers as well. So again, if you think of it like how this applies, data centers also do this, not in the blockchain, they don't, but they have data centers distributed all over the world. In the UK, they have, Azure has like 2. So in case one goes down, the other one takes over, or one gets hacked. Again, they're just distributing there and reducing their risk of, if they only had one data center for the whole world and that went under, it would be a security risk and also a business risk. So be thinking distributed is the kind of way going forward as well. It adds to security as well. So that's the difference. We've got a centralized way, which is one database, one maybe server that has it there, or blockchain, it's distributed as well. So again, we can have public blockchains, which everybody kind of knows is Bitcoin. So that's a blockchain technology, and again, that's all Bitcoin is a series of transactions that you keep. We've changed, 2 people have exchanged Bitcoin coins, and that transaction is then added to the blockchain. So that's a public one, and that's what we call permissionless blockchain. You can just get onto the blockchain very easy. All you have to do is set up the software on your computer, and then you're part of the blockchain. After you get a private key, actually, as well, to kind of get. But again, it's freely to kind of get on. A private blockchain is something really where supply chain management applies to. Again, we don't want everybody adding to go. If we're a supply chain management company, or we're in part of the supply chain and there's blockchain in it, we only want people that are taking part in the supply chain to be added to it. So it's a private blockchain or permission-based blockchain. So somebody has to add you to the network, and then you get a copy of the database and all the transactions that kind of happen there as well. So again, think about an example. There's Liberty IT in Belfast, and they have a private blockchain with 10 other insurance companies. So that's how they kind of they're like, I don't know if they're fully managing it, but they're looking at the ways of manage all their policies and stuff and automating a lot of things. So again, they kind of trust. Now they're not using Bitcoin or anything. They're still transacting money, but they're using the security and the blockchain way of working to kind of do that. So after you kind of doing supply chain, you might have 10 companies within a supply chain, and then you're adding the supply chain as they're doing the work. So again, it's just that's a very basic of permission-based blockchain. Again, everybody has a copy of the database, which is distributed then. Again, I just want to talk about something about smart contracts. A lot of people talked to me about smart contracts before on blockchain and how it could automate and take out middlemen like, insurance companies or maybe banks and stuff. Smart contracts are like really like the real world contracts, the physical contracts that we have. On a contract, we say between 2 parties how this relationship is going to work. And, if anything foul happens, how we're going to remediate that and how we're going to pay for that. So again, it's all the steps that are in it. In smart contracts, they're really the same thing. They're not smart. The only reason they call them probably smart is you can automate some of this stuff with that's in a contract. So say if in our contract we have for supply chain is we say the relationship between us is I supply you goods and you pay me the money. So that's the contract. So what happens in the real world, you come I supply you goods and you pay me the money. So what happens then is I supply you the goods, I come to your factory and I supply you with the goods and you take down the order, you say, yeah, I've delivered it, perfect. And then, maybe when somebody in the office gets back to it, they'll pay me the money and stuff like that. So that's, in the physical world, maybe a contract. So maybe what we can do is automate a bit of this as well, using the kind of blockchain and smart contracts as well. Is we can say, if I deliver the goods to your factory and I weigh them, and I have an RFID tag on my truck, and it says, yes, you delivered it. We know who you are. It is coming in at weight. There's a smart contract listening out for that event from the weighing machine. So it's listened for an event, and it goes, yeah, we've got the RFID, we've got the weight. That person will be paid now, and they do an automatic. They call an API to the bank system, and they just transfer the funds straight away. And again, what they can do is then put that kind of transaction that happened on the blockchain, just to say, here, money was changed, and this is what happened, and this is the information about it. And again, that's where the smartness is, they call it, is it's just kind of automated. The steps we have to do in the contract are kind of automated in code, so that's it. So again, we'll just bring it through here. Is the option is an option contract is written as code into a blockchain. And then an event, you can just think about it. We have events all the time. Our phones give us notifications. That's an event. If you have a banking app, you get notified then if there was a lodgement into your bank account. That's an event. And again, a machine can listen to that and do actions based on that. And again, that's what the blockchain smart contracts are looking for. It's just events, but you program those in. So an event, a delivery of goods and expiry date, triggers an execution of coded terms in the contract. Again, it's just saying, I will execute the money transfer on the banking API, so make sure the money is transferred. And then assets are released to the necessary parties. And again, regulators can study the immutable transaction records, because again, remember, we have a history of transactions. We can't change them. It's very hard for a hacker to do. Regulators can come along and say, look at your history. Again, I don't think it's good for years before they can start looking at blockchain histories as a way of auditing and stuff. So, but it's a way, it can definitely help with audits and stuff like that. So again, a smart contract, not as smart, it's just doing the steps in code for you, really what you're doing in the physical world. So, just to give you kind of brief overlook then, we've kind of just understood what blockchain is. It's the database of transactions. We can't really change that information. It's very hard for hackers compared to a normal database, which can be changed very easily without any history. So again, we've kind of applied it to a supply chain here. We're just giving you kind of how it could work. So imagine we have the Northern Ireland food blockchain, and everybody can kind of add their information to it, and certain people can subscribe to that information, and other people can upload their information. So people are listening can kind of find out, oh, the supplier has enough food, we can buy that off them. That's the kind of transparency. So we can look at the start there, at the start of the blockchain, is uploads data of antibacterial fodder or cows tagged with RFID proving that's free range. Again, if you think about the horse meat scandal, the problem they had there is somewhere along the supply chain, horse meat got in and was mixed around with more cow meat. They don't know where it happened, but it was all the paper-based supply chain. So it was all paper-based, people signed on as they went through, and somewhere along the way they messed with the paperwork as well. So their quality assurance there was messed up. So again, it got to consumers then in the end. Again, what we can have here and what we have to have in every supply chain is QA, is quality assurance in every point. So then when we were looking back at the transactions of, say, some meat that was delivered to us, we can actually go back to where maybe QA could have failed there. So again, we want to make sure, but as well, actually, one thing is the blockchain is not going to solve that people put in wrong data. You still put in wrong data, but at least you can find it and lies. So go back to the supplier. So again, we've got that information on the blockchain. We know this cow has an RFID tag, it's free range. We can track then how that cow is broken up then into the different parts of the meat. So a producer then gets the information on the cow and is designated beef products and cuts and prepares meat accordingly, adds QR to the packaging again. So that information is added to the blockchain as well. And again, it's a series of transactions. Distributor automatically receives notification about receipt of products. Again, a distributor can get events going. Actually, the producer is put on the blockchain. He's saying, I've got 100 packs of meat now. I've prepared them. distributor can automatically then get those events. And then he can kind of automate some stuff going, okay, I want to choose a certain third-party logistics company to start delivering this for me straight away. Again, you're thinking about that automation now. Like a distributor gets these events, they could have a smart contract saying, actually, if the producer comes in with 100, let's actually call 3PL guys, and they'll automatically do it for us. So you can think about that. Again, this is the transparency. So 3PL is informed of the origin, the destination of the beef products, reviews instructions how to store, flexibility. Again, this is some of that information is stored on the blockchain that it will need. And then the retailer can run learning-based forecasts, and then you can actually see how long the blockchain or the supply chain is taken from the supplier to himself. You can do a lot of analytics on it as well. Right? So again, you can provide an app to the end customer as well to say, here, look, if you buy our meat, we know exactly where it's coming from, because we have a history of series of transactions of where it's coming from, and we can instantly do that as well. And the store has full transparency on delivery time and adapts orders, promotions, goes against. If you can see down the line, actually, we're going to be having a lot of potatoes. Maybe you can kind of say, okay, we're going to have a special offer on potatoes straight away, because we can see down the line there's a lot coming through, and then they can kind of be proactive instead of reactive there. So again, actually, that's happening in Belgium at the moment. Is they have potato warehouses now, because there's not enough people buying potatoes, because they would normally go to restaurants or fast food places there. So they're actually asking people to eat more chips. So again, they'll probably have some promotions there at the moment. But it's again, it took them a bit of time to understand themselves. And then the customer gets at the end, they kind of, they can get insights into the origin of the beef, the age and duration, and get some recipes as well. But also as well, a lot of people are thinking about where their food is coming from these days, so you want to have that kind of traceability, but you don't want to be like tracking it, with a QR code. You want to just have one system where you can track it all, because in this blockchain in this supply chain currently at the moment, there's multiple different systems. A supplier might have a different system to producer, and the supplier will upload to the producer's kind of system. And then the distributor doesn't have access to the producer's system, but the producer then uploads. And again, it's all over the place. And if anybody wants to find out, where does maybe if this meat's come from, or, where the problems are, they have to go through all these systems. And again, that's what we want in a blockchain. We want one whole system. Everybody uploads, everybody has different permissions, and that really helps then with the whole tracking of it as well. So think about that. We have multiple different systems at the moment in our supply chain. Some are paper-based, maybe some are like, computer-based, but they're all different systems and they don't always talk to each other. And sometimes you have to actually ring somebody to kind of get the information. Again, it's quite complicated as well, based on that. So yeah, that's kind of how you can kind of apply blockchain to it, to the supply chain. So again, I just want to show you some, just some proof of concepts I did. I'm not showing you the proof of concepts, but the software you can kind of use to make your own kind of blockchain if you want to apply it to your own system, or you want to just try it out, that way. So there's one called Hyperledger Fabric. It's an open source project. It was started by IBM, so IBM are kind of adding to it. But it's a one that you can kind of trial out the different ways you can use blockchain in your supply chain. So it's built for supply chains as well and transactions. So it's quite a handy one. And just to kind of show you Hyperledger Fabric, it's think of it, it's a permission-based blockchain. Only people you want to be a part of your network is added to the blockchain network. So really what it's doing, Hyperledger Fabric, is you can define contracts on it. Again, you can define smart contracts and you can invoke them. But really what it's keeping track of is a database. So it keeps its own database. And every time that database changes, maybe there's some information changed on a table, it creates a hash of that information and puts it on the blockchain. So you constantly, what it calls a world state. It knows the state of that database is going through, but also has a history of that database, and it's hashed and it's kept encrypted. So again, you can kind of trust it then. So you've got a history based on it. So And again, I think it's quite a good one. Again, especially open source one. A lot of companies kind of get involved with it as well, like it's using it as a basis. Like so. Yeah, I just want to kind of go through the pros and cons of blockchain supply chain. There's just a few of them there, pros and cons. Like, so you have greater auditability. So you can kind of look through the history, so anybody can check it there, and you can kind of view it. Also traceability, you can kind of look through the back through the whole blockchain and kind of trace back stuff there. And again, so that's kind of pros of it. And it's kind of security wise, again, like I've talked about, you know, if we have loads of people on the network, everybody has a copy of that database. If somebody has to hack into every database to change it, that's fine. But the more people are on the network, the harder it is to hack because it takes more time. But also we have the second layer where actually they have to change all the blocks in the chain as well. So we got those kind of two layers if you think about it, like, so security. Cons on it, it's just a bit more complicated than the normal databases at the moment there. So I kind of see that maybe in the future we'll have a kind of SaaS products. SaaS is software as a service, just like Office 365 is a software as a service, or Gmail, you know, we just log on, we don't have to set up a server ourselves or anything. I think that's how it'll kind of come along, and we'll have databases or that are backed by blockchain then, so we can kind of see the history. So other cons, yeah, just a bit more complicated, and you know, to get developers as well to make smart contracts is a bit more harder because they're a bit more there's not as many of them out there to kind of make these kind of contracts in code. So that's, yeah. So just some pros and cons, but it's not too many. Just to kind of finish off on the last slide as well, just so we actually spent a bit more time than I thought. This Romani lettuce there. So just to kind of show you like how Walmart in America, they have their actual own blockchain for supply chain management. And the only difference between it, and remember we were talking about the whole centralized way and the distributed way, which blockchain is kind of used to. There, Walmart owns the network, and they're the only ones really on the network. So they have a really so they've taken blockchain and really centralized it as well. So I think they've just used it for maybe the block, the actual block level security as well on it. So nobody gets the copy of the database. They're the only ones to do it. So all their suppliers then supply information then to their systems, and it goes into the blockchain. Again, it's easy then for Walmart then to kind of trace any products back to their origin as well. So kind of like, so there was an E. coli outbreak that affected a lot of lettuce. So what happened there was they just discarded all the lettuce, and you know, there's a lot of food waste. Not all the lettuce, they didn't know where it actually came from, the actual problem, so they just discarded it all. So again, with the whole blockchain, they can kind of trace it back, like saying, okay, this farmer probably through our quality assurance is the actual problem. Any lettuce that came from this farm, destroy it, instead of all the lettuce that was supplied to Walmart then. So again, just to show the speed of it as well. So last year as well, Walmart conducted an experiment trying to trace the source of sliced mangoes. So it took about 7 days for a Walmart employee to kind of like locate the farm in Mexico where the fruit was grown. Again, it's just, there was different systems. It was all like paper-based, different systems by supplier and stuff like that. With blockchain software then, which IBM provided then the mangoes, they could track back then to the farm in seconds. So again, they knew exactly where the problem was. They can react to it very fast. If there's any problems with the fruit, any diseases, they can kind of track it. So again, it's just showing the how quick it would be like, so on that. So yeah, so that's kind of the different ways you can kind of the different basics of kind of blockchain. There's also a company in Belfast called Downstream Beer, and they also have so their beer is created, but you can also, they put all the information as they're going through the whole supply chain process, which is a big supply chain, and it's added to their blockchain. And then you can go get an app, you can scan the code on the can, and it can tell you actually where that exact barley came from for that can. So again, they've put all the information together, like so. That's one company in Belfast that's kind of started to use the thing. Again, they're relying on people wanting to know where their beer came from, and again, in the future, more and more people will want to know where their food from, especially with climate change happening and diseases happening a lot more frequently. They'll want to know where their kind of stuff comes from. So, yeah, I was just wondering, Dave, take over here. If there's any questions there, if any people have any kind of ideas.
Yeah, I'm just going to go through there's been quite a lot of chat actually while you've been on, a discussion on the group chat and some questions. So I'll just run through a couple of them, and I might be a bit pushed for time, but just quickly, first one from Kathleen M has asked, is a ledger like a logging tool?
A logging tool, like?
No, just the question is a ledger like a logging tool? And then I suppose there's another question quickly from Kathleen as well, is if you cannot unhash, what if you stored something with an error? Can you mark it as faulty, delete it, make it inactive, or run an update to overwrite it? So if you put something in error.
Yeah, no, it's still there. It's always there. That kind of way. It's you just have to update it again, and just goes on to the next record, onto the next block then. And then that's, so if you do a mistake, it's just in the history, so you can't undo it. So
okay. And then
that's one thing people don't like. They're like, oh, what if I put something on? Can I take it off? No, it's always there.
So all mistakes are traceable. Whether
it's just tracing. It's a history of transactions. So as long as you update the database again, you have the latest correct information. It's just like if you go back.
Yeah. So, and then we have Kieran Kelly, who's just sort of pointed out that recognizing how important transparency in our food supply chain is, and just sort of stating it's a great example of where blockchain can add value.
Yeah, exactly. Yeah. And if you think about it, if we had some kind of Northern Ireland kind of blockchain, kind of supply chain that people could use, again, we don't want every little business or every farmer coming up their own blockchain. We want to kind of like maybe a Tesco one or Marks & Spencer, they all got in,
No worries. We've got Pamela Dennison has asked, can this be used to assist with NI protocol / HMRC customs to reduce checks?
Yeah, they could reduce checks there, but they're also, it could speed up the whole Brexit that's going to happen. Again, people are worried about the whole the amount of paperwork that's going to have to be done. It can speed up all that paperwork. As you're coming along, there could be something where you're coming towards customs, you're transferring your information over the network, and you're saying, I'm coming to the customs, it's already on a blockchain, they can kind of check it there, but they're also always going to do the physical checks. They just randomly do those, because you can also lie, but it can speed up that as well.
No worries. And then I think someone might have answered it in the questions, but I'll put it to you in terms of what are the gas fees in Hyperledger for the final user that scans a QR code?
What's the fees, is it?
The gas fees in Hyperledger for the final user that scans the QR code. And
what can they say? What the, it's an Ethereum thing I was thinking about there. I can't think off the top of my head on that, but then it's your own kind of network that you set up.
So I just wanted to say thanks very much to everyone for dialing in to this latest Webinar Wednesdays, and thank you for Martin for sort of breaking down what blockchain is, and also some ideas of how that could alleviate some supply chain issues. Even before COVID-19, it was a massive issue, but probably more so after that, and with Brexit coming down the line. So thanks very much, everyone. Enjoy your afternoon.